Annuities are probably the most important concept for you to understand and be able to work with in financial mathematics. They are found in all different types of problems and are used in many different ways. And so it's important for you to develop a skill set surrounding annuities. And that skill set should involve some little tricks to help you do things quicker or help you make certain scenarios easier to work with so that you can solve a problem faster or solve it more efficiently. In this video, I want to talk about a particular annuity trick that I think you might find helpful. It's not something that you will use in every single problem involving annuities, but there are specific cases where this might be helpful. And this annuity trick I'm referring to has to deal with something called block payments. And so naturally, before I show you this annuity trick, we do have to ask the question, what are block payments? And well, remember, annuities deal with streams of payments or a series of payments. And so when payments for an annuity stay level for a period of time and then change to another level for another period of time, and then maybe they change to another level for another period of time, and so on, that is what we call block payments. There are blocks of different sets of payments that make up one stream of payments. All right, and to give you a better idea of what I'm talking about here, let's take a look at a visual. Here I have a timeline where we have a series of 18 payments, but not all of them are of the same amount. The first 5 are all $3 payments, the next 3 are $6 payments, then the next 6 are $5 payments, and then the last 4 are $1 payments. And so you can see that we have 4 different blocks of level payments, all right? This is different than something like an arithmetic annuity or something like a geometric annuity where the payments are changing with some kind of pattern, whether that be a geometric progression or an arithmetic progression. That is not what is going on here. There's no clear pattern that we can represent with some kind of formula. These are just different blocks of level payments. And so to really nail down this visual, if we were to sort of turn this timeline into a graph, we'll let the horizontal axis represent the value of time and the vertical axis be the amount of the payments, or in other words, the dollar amount for the payments. What we could do is sort of make a bar graph here where you will see the actual blocks for these block payments. All right, for the first 5 years, we have those $3 payments, and so we have represented that with this bar in this graph, or as we're calling them here, this block. So we have this block of 5 payments where they're each $3. Then we have this block of 3 payments where they're each $6. Then we have this block of 6 payments of $5, and then we have this last block of 4 payments of $1. Okay, so this is what I'm talking about when I'm talking about block payments. We are talking about sets of level payments where that level changes throughout the course of the series of payments. All right, so now that we've established what block payments are, now let's get into the actual trick, because something that you might actually be asked to do for a series of payments like this, where you have block payments, is you might be expected to calculate their present value. There's actually 2 main different ways that you could go about it. And I want to start by showing you my usual method, or the method that I think makes the most sense intuitively if you're just using what you know about how we value series of payments at time 0 to calculate their present value. But then after I show you the usual way that you would go about it, I'll show you the trick, or a new method that you might like better. Not everyone will like it. Some people, some people don't. That's totally fine. It ultimately comes down to your preferences, which way you want to do things. But the purpose of this video is to just make you aware of this trick and how to use it. Okay, but to get started, let me just show you how I would typically go about calculating the present value of these block payments. Remember that the present value is valued at time 0, so I'm going to circle time 0 so that you can see visually where we are going to value all these payments. And what I would do is I would start with the first 5 payments of $3. Using annuity notation, which if you're not familiar with that, be sure to check out my video on the present value of annuities that you can find in my financial mathematics series. The way that I would go about calculating the present value of these 5 payments of $3 is to take that payment of $3 and multiply it by the present value notation for an annuity immediate. So we'd have A, and then we have 5 of those payments, so 5 bracket, and then the interest rate I. Now in this case, we don't know what the interest rate is. That's okay. You can just write I. Okay, and all of these payments are being made at the end of each period, so we are working with an annuity immediate here and not an annuity due. But that takes care of the first 5 payments. This notation, A5 bracket I, calculates the present value of a series of 5 payments of $3. Specifically, it values those payments one period before the first payment, right? That's what this notation does. So keep that in mind as we move on to the next 3 payments, because what we're going to do is add the present value of these 3 payments. So we're going to write 6 and then A3 bracket I, right? That would represent the present value of 3 payments of $6, but where would that actually value the present value of these payments? Well, as I just got done saying, this notation for the present value of an annuity immediate values the present value of the payments one period before the first payment, right? So this right here, 6A3 bracket I, does not value these 3 payments at time 0. It values them at time 5, okay? One period before that first payment. So to actually value those 3 payments at time 0, we need to bring this notation or this value back 5 periods, okay? So we would multiply by a present value factor to the power 5. Okay, so that would take care of those 3 payments. Now, following a similar pattern, if we add the next set of payments, or the next block, we have 6 payments of $5, so the present value would be 5, and then A6 bracket I, but that is going to value the present value of those payments one period before the first payment, which would be at time 8, so we need to multiply by a present value factor to the power of 8 to bring that value back to time 0. And by the way, those present value factors would still be using that same interest rate I, which would be an interest rate that matches the period cycle of these payments. In other words, if each of these times represents a year, then that better be an annual effective interest rate, not a monthly rate or something like that, okay? The period type and the interest rate need to match in terms of frequency. Now, finally, let's move on to our last set of payments here. We have 4 payments of $1. So to calculate their present value, we would have 1 multiplied by the annuity notation, but anything times 1 is just itself. So we're just going to have A and then 4, because we have 4 of those payments, bracket I, okay? But that's going to value the present value of those 4 payments at time 14, which is 1 period before the first payment. So we need to bring that value back 14 periods by multiplying by a present value factor to the power of 14. Okay, and this right here is how you would calculate the present value of all of these payments. That is the usual method, or the way that I would go about it, using what we know about annuity notation and how we typically calculate present values of annuities. But this admittedly is not going to be very nice when it comes time to plug all of this into a calculator. If you're using a financial calculator such as the BA2 Plus, it can be a little bit annoying to calculate some of these annuities and multiply them by a present value factor. It's not impossible, it's nothing that you can't do, but it can be a little bit time consuming and involves a little bit extra work than if you just had plain old annuity notation not being multiplied by present value factors. And so that is where the trick comes into play. This is now where I want to show you our trick for calculating the present value of block payments. I moved our first method up here so you can compare it to what our new method is going to produce. But before we write down any notation or any calculations, there's a little bit of prep work. There's some things we want to do first with this timeline. What we are going to do is actually break up this stream of payments into several streams of payments where all of them start at time 1, or in other words, they start at the end of the first period. So the way we're going to do that is by first looking at the last set of block payments. Or in other words, you want to look at your last block. In this case, we have $1 payments for the last 4 periods. What we want to do is pretend like all 18 payments were of $1. So if that were the case, we would have something like this. We would have $1 at the end of every single period for 18 periods, including those last 4 payments. But remember, those first 14 payments are not just $1. There's actually more than $1 there. So we're going to have some money left over after working with these 18 payments of $1. So if you subtract these dollars from their payments at the respective times, this is what you're going to have left over. You're going to have $2 payments for the first 5 periods, then $5 payments for the next 3, and then $4 payments for the next 6. Okay, we subtracted 1. I'll just put this in parentheses. We subtracted 1 from these payments to get these ones. If you subtract 1 from these 4 payments, obviously you just get 0. That's kind of the idea here. We have one set of 18 payments of $1. Now we have a new set of payments where we still have blocks, but now we only have 3 blocks instead of 4. So you can see we are slowly decreasing the number of blocks we have. We're actually going to do the same thing we just did for that 4th block, but now for the 3rd block, or this block right here of these $4 payments. But now instead of having 18 payments of $1, we're going to try to make 14 payments of $4. Okay, so if we do that, if we want to have $4 payments at each moment in time, we will have to subtract $4 from all these payments. For these 6, we're just going to be left with 0, but then for the other payments, 2 minus 4 is -2, so we're going to have a payment of -2 for the first 5 periods, and then 5 minus 4 is 1, so we will have $1 payments for the next 3 periods. Okay, and by the way, we subtracted 4 to get those payments. Now we have 2 blocks left. Let's continue the pattern here. Now our last block is 3 payments of $1, so once again, we want to try to have a full series of $1 payments, and in order to do that, we will need to subtract 1 from these first 5 payments. Okay, so we're going to have a $1 payment at each moment in time for 8 periods, and so if you subtract 1 from each of these payments, the first 5, you will have 5 payments of -3, which will give you the last set of payments. So let me just draw that in here yet. We're going to have 5 payments of -3. Okay, so to get that, we subtracted 1. All right, and so now, here's where we start to put everything together into an equation. And by the way, I know this seems like a lot of work right now, but it actually goes a lot quicker once you see how it's done. We will look at another example before this video ends where I will really speed through the process and you can see how fast it can be. But for the first time here, I really wanted to sort of explain what's actually going on before we start speeding up the process. Okay, but what we now have are 4 different sets of level payments where they are level for the entire stream of payments. And here's where they are. We have the first one here where we have 18 payments of $1. Then we have the next one here where we have 14 payments of $4. And then we have our last 2 down here where we have 8 payments of $1 and 5 payments of -$3. And so we can calculate the present value of those payments like this. Since each of those 4 streams of payments start at time 1, we can just use our regular annuity immediate notation and not have to multiply by any present value factors. Starting with the series of 18 payments of $1, we'll have 1 times A and then 18 bracket I. Then we'll add that to our next stream of payments where we have 14 payments of $4. So we have 4 times A, 14 bracket I, and then we'll add that to our next stream of payments where we have 8 payments of $1. So we'll have 1 times A, 8 bracket I, and then we'll add that to our last stream of payments where we have -$3 for 5 periods, or in other words, 5 payments of -$3. So really, instead of adding this, what we want to do is subtract. We're going to have minus 3 times A, 5 bracket I. All right, and that right there is another way that you could calculate the present value of our original set of payments, or these 4 blocks of level payments. This right here, this calculation is mathematically equivalent to this one up here. But as you can see, this would be a little bit more complicated to plug into your calculator, specifically a financial calculator, than this down here. This would be a whole lot easier to put into a BA2+ calculator. You could calculate the present value of each of these individual annuities and then add and subtract them appropriately to get your final present value, whereas if you were going to do that up here, you would have to do some in-between steps where you multiply this present value by v to the power 5, this present value by v to the power of 8, and this present value by v to the power of 14. And so you can see how this would be a whole lot easier to do with a calculator, which is maybe something that you want to do. Okay, so now that I have demonstrated this annuity trick for block payments, let's sort of solidify our understanding here and work on an example problem before we close out this video. Hey there, real quick, before we move on to the next part of this video, if you are currently studying financial mathematics with the intent on taking the exam FM, then I want to give you a gift for watching this video today. I want to give you my free 6-week studying strategy guide for exam FM. Inside the PDF file, I lay out a reasonable studying timeline that you can follow to prepare for the exam FM in just 6 weeks using my own content as well as some other resources online. By all means, it is not the only way to prepare for the exam, but it can certainly help you get started. So if you're struggling to stay organized in your studying of FM topics or want an easy to follow schedule for preparing for your exam, then this guide is for you. And it's absolutely free. Just head on over to jkmathematics.com/studyfm 6 weeks. Once again, that's jkmathematics.com/studyfm 6 weeks. Or you can find the link in the description. Okay, now back to the video. Okay, so here's our example problem. We want to calculate the present value of the year-end payments described by the table below using an annual effective interest rate of 6%. And so we're told that the payments are year-end payments, so we know that we are working with an annuity immediate. We're not working with an annuity due, although this trick would still work for an annuity due, as long as you remember how that formula works and where it values the present value of a series of payments. But to stick to our specific case here for this example, we have a stream of payments where they are divided into blocks of level payments. From year 1 to year 4, we have payments of $7. From year 5 to year 12, we have payments of $16. From year 13 to 21, we have payments of $25. And from years 22 to 24, we have $19 payments. All right, so the first thing that I recommend that you do here is draw a timeline. Let's draw out all the payments we're working with, and then we can use our annuity trick to calculate the present value of these payments quicker. Okay, so here's my timeline. This right here will be time equals 0, and we're working with a total of 24 years. So this last date here will be time equals 24. And so in the middle here is time equals 12. Right here would be time equals 6. Right here would be time equals 18, and then I'll fill in the rest here. Now to fill in our payments from years 1 to 4, we have $7 payments. So we have 7, 7, 7, and 7. Then from years 5 to 12, we have $16 payments. So 16, 16, 16, 16, 16, 16, 16, 16. Then from years 13 to 21, we have $25 payments. So we have 25, 25, all the way up to year 21. And then for the last 3 years, from year 22 to year 24, we have $19 payments. So we'll do 19, 19, and 19. Okay, now I'm going to write out a lot less work than I did last time. I'm going to show you how this method is a lot quicker. In fact, as you practice this, you can probably get to a point where you don't even need to draw a timeline, but I always find it helpful to draw one anyway. It really helps me to visualize these different annuities that we're going to create via this trick. Okay, so we're going to look at our last block here where we have $19 payments. When we calculate our present value at time 0, we're going to have a stream of payments where we have 24 payments of $19. Okay, so the first part of our equation here will be 19 times A 24 bracket I, and in this case, our interest rate I is equal to 0.06. It's 6%. I'm not going to write 0.06 in each time, but you would use 0.06 in this formula. This right here takes the present value of 24 payments of $19. Since we're doing that, we now need to subtract 19 from the rest of our payments that are not $19. Although I guess technically we're still subtracting 19 from these, we're just left with 0 afterwards. But doing that will give us some new payment amounts. 7 minus 19 is negative 12. So we have negative 12 for the first 4 years. Then 16 minus 19 is negative 3. So we have negative 3 for all these payments. And then 25 minus 19 is 6. So we have $6 payments at each of those times. Now, what we want to do is take the present value of 21 payments of $6. All right, we're looking at our last block again. It's not 19 anymore, it's now 6. We took care of those $19 payments. Now we're moving on to our new final block, and we want to have 21 payments of $6. So we're going to add 6 times A, 21 bracket I, and so now we're going to subtract 6 from all of our remaining payments. So if we do that, negative 12 minus 6 is negative 18. So we'll have negative 18 for the first 4 payments. And then negative 3 minus 6 is negative 9. So we have negative 9, negative 9, negative 9, all the way up to year 12. And so now we can actually move on to our new block here. We have negative $9 payments that we want to account for 12 years. So our next part of our calculation for the present value will be minus 9A 12 bracket I. We want to have 12 payments of those negative $9. And now finally, we need to subtract negative 9 from our first 4 payments, and negative 18 minus negative 9 will be negative 18 plus 9, which will be negative 9. Okay, so finally, we will have negative 9 once again, but only for 4 payments this time, so we will have minus 9 times A for bracket I. And that's it. This right here will calculate the present value of all of these payments. And now, just to show you that this is indeed quicker to put into your calculator to calculate the present value of these payments, I'm going to do it for you here real quick. Here is my BA2 Plus calculator. I'm going to start by calculating this present value right here, 24 payments of $19 using a 6% interest rate. First thing I'm going to do is clear out my time value money buttons in my calculator. I do that by hitting the second button and then the future value button, because above the future value button it says clear TVM. So now we're good to go. Everything's cleared out. We have a blank slate to work with. We have $19 payments, so we'll do 19 as the payment amount, and we have 24 of those payments, so we'll put in 24 as the value of N, and then our interest rate is 6%. So we'll have 6 as the interest rate. Okay, then I'm going to hit compute present value, and there's the present value of that first annuity. Notice that it is negative. That's because I put my payments in as positive. If you wanted the present value to come out as positive, put your payments in as negative, but it'll get you the same answer either way. I'm just going to make it positive by hitting the plus or minus button, and then I'm going to store that in my calculator and bring it out later after I calculate these other annuities. So I'm going to hit store in the 1 button. We'll come back to that. Now let's move on to our next annuity. We have 21 payments of $6. So I'm going to clear out time value money and start over. We have $6 payments and 21 of those payments, and the interest rate is still 6%. I'll hit compute present value. There's our next present value. I'm going to make it positive and store it in the 2 button. Now let's clear out our time value money again and do the third annuity. This one is negative, but I'm going to wait till later to take that into account. What I'm going to do is take each of these present values and then add these two, subtract this one, and subtract this one. Okay, so forget about the negative signs for now. We'll come back to that later. We have $9 payments, 12 of those payments, and a 6% interest rate. So let's now compute the present value, and then we want to make that positive and store it in the 3 button. Now let's work on our last annuity. We have 4 payments of $9 using that 6% interest rate. So once again, I'm going to clear out the time value money, then we'll do $9 payments, then 4 of those payments, and a 6% interest rate, compute the present value. Now that already came out as negative. I'm going to leave it like that because it technically would be negative. Then what I'm going to do is add the present value of the first 2 annuities here, which I stored in the 1 and 2 buttons. So I'm going to hit plus recall 1, hit equals, then plus recall 2, hit equals, and then I want to subtract this present value from that third annuity we calculated, which I stored in the 3 button. So I'm going to subtract recall 3. And there you have it. Okay, the present value is equal to $202 and about 40 cents. That's the final answer to this problem, but this is not the only way that you could have gotten this answer. There's actually an even quicker way that you could calculate this in your calculator without writing down all of this work. And this is sort of the ultimate trick, I guess you could say. What you can actually do is just make use of the cash flow feature of the financial calculator, and you can sort of bypass all of this work. Okay, so let me show you that yet. I'm going to clear out my work here, and then I'm going to hit the CF button for cash flows. And you might have something in here already, so you're going to want to clear that out. Hit second and then clear work. Now you should be good to go. CFO or CF0, that's just your cash flow at time 0. Don't worry about that. Leave that as 0, so hit enter and then hit the down arrow. C01, that's going to be our first cash flow, which as you can see on our timeline would be our $7 cash flow or $7 payment. So I'm going to put in 7 as our payment amount, hit enter. And then when you go down where it says F01, that stands for the frequency of that first cash flow. Usually we leave that as 1 because typically we don't work with repeating cash flows, and if we do, we just treat them as annuities. But in this case, we have a lot of payments, but they're not all the same, so we can't just use a regular annuity formula. And so that's where this frequency feature is really nice in the cash flow function here. We're going to set the frequency to 4 because we have 4 of those $7 payments. Now if we go down to C02, our next payment amount or next cash flow that's different is $16 at time 5, right? So I'm going to put in 16 for cash flow 2. It doesn't matter that that's not C05 or time 5. The calculator knows what's going on here. It knows that we had 4 payments of 7 and then we're moving on to 16. We just have to make sure to tell it how many of those $16 payments we have. So I'm going to go down and the frequency will be what? 1, 2, 3, 4, 5, 6, 7, 8 payments of $16. So the frequency is 8. So I'll hit 8, enter. Go down to C03. Our next set is $25 payments, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of those. So 25 is the payment amount, and the frequency is 9. And now finally, let's go to C04. We have 3 payments of $19. So I'll do 19, enter, and then the frequency is 3. So put 3, enter. And now here's the cool part. Go to the NPV button or press that. And then you want to put in your interest rate. In this case for us, it's 6%. So we'll do 6, enter. And then if you go down, you can hit compute net present value. And would you look at that? We got the same answer of $202.40. Pretty neat, right? So there's a lot of different ways that you could go about calculating this present value. I just showed you the really quick method of doing it in your calculator. Some people don't prefer to do that though. They'd rather work it out the way that we did here using this little trick. But you might also prefer to do it the original way that I showed you at the very beginning of this video, where you just worked with each set of payments individually and valued them at time 0 using both annuity notation and present value factors. Which, by the way, if you wanted to know what that looks like for this example, I'm going to write it down really quick. And if you wanted to, you could check and see that it would also give you the same answer of $202.40. All right. The present value would be equal to those 4 payments of $7. So you'd have 7A4 bracket I. Then you'd add that to the 8 payments of $16. So you have 16A8 bracket I. But now that present value would need to be brought back 4 years. So you'd multiply by v to the power of 4. And then you'd add that to the 9 payments of $25. So 25A9 bracket I. But then that would need to be brought back 12 years or 12 periods. So you'd multiply by v to the power of 12. And then you would add that to the last 3 payments of $19. So you'd have 19A3 bracket I. But that would need to be brought back 21 periods. All right, for each of those sets, I'm just looking at the time before the first payment to decide how far back to bring it back in order to value those payments at time 0. Okay, so we're multiplying by v to the power of 21. And of course, each of those present value factors would use that interest rate of 6%. All right, so if you do want to check that, you can. I'll just write, or you could do it this way. And remember that a(n) bracket I is equal to 1 minus v to the power of n divided by I. and that a present value factor v to the power of n is equal to 1 divided by 1 plus I to the power of n, okay? Just in case you forgot what those different notations mean or what they're equal to, those are the formulas that you need to know. But with that, that concludes this video on an annuity trick for block payments. I hope this was very informative. I hope you learned a lot of different ways to deal with annuities that are structured in this way, that are structured in blocks. You can either do it by using annuity notation and present value factors, or you can do it by just using annuity notation by sort of splitting up your payments into sets of level payments that all start at time 1. Or you can just straight up use your financial calculator with the help of the cash flow function. All 3 methods are viable, but obviously some of them are quicker than others. Specifically, the calculator method is probably the fastest, followed by this method of splitting up your payments, and then finally, this method right here that I just wrote out is definitely the slowest, although it probably makes the most sense conceptually for most people. Okay, so whichever method you want to use is fine. Just make sure that whatever method you use it correctly. Okay, if you have any questions about anything I talked about in this video, please leave them in the comments. But if you don't have any questions and you found this video to be helpful, feel free to check out some of my other financial mathematics videos. I have an entire playlist of all of my FM videos that you can take a look at. But with that, that's it for this video, so I'll see you next time.